Project 4 of rtos. This is a group 6. The outline for this presentation: firstly, we are going with introduction, then hardware and software we used, then the implementation steps, results, and references. So coming to the introduction, the main aim of this project is to build a home sensor system using ESP32 module, which we already know. So we have used various sensors, namely temperature and humidity, light sensor, gas, and particle sensor. So firstly, when we connect the ESP32 module, we connect with Wi-Fi network, which asks for a password. So here, all the SSID, password, serial number, Unix system are stored in a non-volatile memory so that the data will not be lost when there is a failure in the power. So the password required for the system is encrypted using Argon2 algorithm. And we have used NTP servers, which is connected using Wi-Fi module to give the current date and time of the system. So then coming to the hardware and software, we have used ESP32 module, DHT11, which is temperature and humidity sensor, MAX44009, which is ambient light sensor, CCS 811 digital gas sensor, then particle sensor, voltage divider, and the software used is Eclipse and MySys32. So coming to the implementation, firstly, we go with the Wi-Fi setup. So when the system is first powered, it asks for the password. The device gets connected when the Wi-Fi network, with an Wi-Fi network which is given in the code, and when we type in the password, if the password is correct, then it gets connected. So as I said earlier, the password and all the SSID are previously stored in the non-volatile memory. Then Argon2 algorithm. So this algorithm is used for encrypting the password which we stored in the non-volatile memory. So initially, in order to initialize the function, we have to initialize the library. We have to call the function called sodium init. Now the password which we stored in the non-volatile memory is read by this function, and then it is hashed. So once the system gets finished this hashing function, then it verifies whether the entered password is same with the password which we have stored in the non-volatile memory. So if it is correct, it goes for the further process. If it is not, the system would reset after a couple of unsuccessful attempts. So here the Argon2 is set for encrypting the password. Then we have given configured 2 commands in the system which prompt the reader a user command. So the 2 commands which we configured are set and log. Set, it is to display all the data stored in the non-volatile memory. And here we have a set name equals to value, so which sets the value name to the value. Then if the value is a string type, then we prefix it with the we enclose it with the double quotes. If the value is a numerical type, we have to prefix with the prefix or suffix with like a C language. Then the other command which we configured is log. We have 2 here, log off and log on. One is to disable the screen, and log on is to enable.
Akash, and now we'll look at NTP server. Now first of all, the SNTP stands for Simple Network Time Protocol. Its operating mode is set using SNTP underscore set operating mode, and ESP module is connected to SNTP server using Wi-Fi, and the server name is poll.ntp.org. It gives the current date and time according to the server you got connected to. Now the next one is temperature and humidity sensor. Here we use DHT11 sensor that can calculate both temperature and humidity by calling the device over GPIO on the ESP32. It uses a single wire data bus and requires a specific handshaking procedure. A specific timing mechanism is needed to read the data. It requires acknowledgement for setting up data. The the data pin of the DHT11 module is connected to pin 4. And now we'll look ambient light sensor. Here we use MAX 44009. This module is integrated with photodiode and is based on the I2C light to digital converter to transform light intensity to a digital signal. An on-chip interrupt eliminates the need for continuously polling for data and results in significant power saving. And now next sensor is digital gas sensor. Here we use CCS811 gas sensor, and it's ultra low power digital gas sensor solution which integrates a metal oxide gas sensor for indoor air quality monitoring. It includes an analog to digital converter and an I2C interface that simplifies the hardware and software design. And the next one is MQTT server. It is a machine to machine connectivity protocol. The sensed output data from all the sensor is published in the MQTT server. And the next are functions. These are the code for all the sensor is written using these 4 functions which has same prototype for all sensors. And the first one is open, which is used to initialize sensor values, and the next one is read to obtain data from sensor, and the next is close, which is used to release sensor access, and the next one is control, which is used to change.
These are the results which are generated in MySys32. Here, after connecting the board to the system and it is powered on, it asks for the password. At this point, I press the incorrect password, so it asks me for the correct password again. At this step, I press the correct password. After this, it goes further. At this stage, I press the show. By pressing show, it's displaying all the name, SSID key which have been previously saved. I saved my group name as group 6, so it's displaying group 6. At this point, I pressed help so that it shows all the functions. The required functions are the log and the set which are there. At this stage, I pressed run, so it's waiting for the Wi-Fi connection. Once over here, the Wi-Fi got connected. Once it got connected, it's waiting for the SNTP connection. SNTP got connected, then followed by the temperature sensor values, humidity, gas sensor values, and the light sensor. So it again started to repeat the same.